Welcome back. Now, we've used the fancy dot product to find the angle between two vectors. We found the angle between the forward vector and the vector to the hit location. And of course, we leveled out that vector, so both vectors are parallel to the ground. And we know theta, the angle between them, but we saw that the dot product returns a positive value. It doesn't tell us whether the green vector is to the right of the red vector or to the left of it. We want to know whether or not that angle is positive or negative. That's imperative to knowing the direction from which we got hit. So this leads us to one more vector operation that I'm going to teach you in this course, and it's called the cross product. Here's why we need it. Here's the enemy, and here's the enemy's forward vector. Now, we're swinging our sword and hitting the enemy, and then we're getting this two-hit vector, which we're using with the dot product to figure out the angle between these two. But because the angle is always positive, we really don't know if we're getting hit from the left or the right because this value is always positive. We want to know when that angle should be negative. Here's where the cross product comes in. A cross product is an operation on two vectors, much like the dot product. But where the dot product returns a scalar, the cross product returns a vector. Here's how it's defined. If you have two vectors, let's call them A and B, and these vectors exist in three-dimensional space. The cross product A cross B is defined as the product of their magnitudes times the sine of the angle between them times n, where n is a normal vector, a vector with a length of 1. So A times B times sine theta is a scalar, and a scalar times a vector is just another vector. So we're taking a normal vector and scaling it by this amount. But what direction does this normal vector point in? Well, this formula returns a vector that's perpendicular, or in vector terms, orthogonal, to both A and B. So if A and B are flat, in other words, they lie in the xy plane, then this vector returned by their cross product is straight up at 90 degrees from A and 90 degrees from B. Now, you might be thinking, wait a minute, isn't there another vector that's 90 degrees from both of these? And you're right, there is. It's the vector pointing in the opposite direction. This too is orthogonal to A and B. Orthogonal just means it's at 90 degrees from these vectors, forming a right angle, and the most common word we think of is perpendicular. So which one is it? Is it the one pointing up or the one pointing down? Well, A cross B gives us the vector pointing up. So the order matters here. If we took B cross A, we would get the vector pointing down. Now, you can always know which direction your cross product will face by using your right hand. If you form these three vectors with your hand, where your index finger is A, your middle finger is B, and your thumb is the cross product, then you can always see that A cross B gives you the vector pointing up. This is called the right hand rule. And if you're curving your hand inward, pointing your fingers at your chest right now, trying to form this sign, congratulations, you're now throwing the mathematician's gang sign. Welcome to the club. Now, the right-hand rule is used by mathematicians in universities everywhere, just like the right-hand coordinate system is used in all their math books, but Unreal Engine uses the left-hand rule, so it's actually the opposite in the game engine. So that's an important detail to keep in mind. So if we take our enemy and we have its forward and two hit vectors, and we take forward cross two hit, the right-hand rule says that that cross product should be pointing downward, but since UE5 uses the left-hand rule, it's going to be pointing upward. And that means our theta should be positive. And if forward cross two hit is pointing down, theta should be negative. So it's really the opposite of the right-hand rule. Basically, you would just switch B and A on your index and middle fingers, And that's how you can figure out the cross product for Unreal Engine. Or you could remember the right-hand rule and just know that Unreal Engine 5 does the opposite. So let's see how this works in the engine. So we need to take a cross product. Well, the fVector class has a function for that. It's a static function called, you guessed it, cross product. And it takes two vectors called A and B. So we're going to take the cross product between forward and to hit. And notice this returns an fVector 3D, which we can store in an fVector. So let's make an fVector. We can make it const, and this fVector can be called cross product. Now we know that if this cross product is pointing up, then we're being hit from the right, as that to hit vector is to the right of forward. But if it's pointing downward, then we're getting hit from the left, as to hit is to the left of forward. So we can simply make a comment here and say, if cross product points down, theta should be negative. So we can simply check if cross product dot z is less than 0. That means the vector is pointing downward, and theta simply needs to be multiplied by -1, so we can use times equals -1.f. Now we can easily see this cross product vector by drawing a debug arrow. So let's go ahead and copy one of these lines where we're calling draw debug arrow and simply call it right here. The only difference is, instead of get actor location plus forward for the end vector, we're going to simply add the cross product. So plus cross product, and we'll scale cross product by 100 just to see what it looks like. So we can save, we can do a quick live coding session, and we can grab a weapon and hit the enemy. I'm first going to hit from the right, and there's the cross product. It's pointing straight up, and we see that theta is positive. Now if I hit from the left, I see that theta is negative, and the cross product is pointing down. So this is a great way to see if we're getting hit from the left or the right. And if we're hit from the right, theta is always going to be a positive value. If we're hit from the left, it's going to be negative. So we can check those values of theta to decide which of our montage sections in the Hit React montage we should play. And we'll do that next. Excellent job. I'll see you soon.